Let's have a quick look at the code involved here. So we have a prefab and we have a few scripts added to it. The main script is what is called the reward controller here. And just to reiterate again, this is all customizable. This is just a template just to help you get started. So take a look at this script. Visual Studio. There's kind of a lot going on, but it's not too complicated. Basically, when it starts, we just generate a user ID that's unique. And we save it to player pref, so next time the game loads, it should get the same ID. We start Quago. If the app token's not set, it won't start it, and if it is set, it just you just tell Quago to init and begin tracking with the user ID. And this user ID is what we use on the Beamable microservice to look up and get the status of the player to see if they have been cheating or not. After that, we really just we call this function check time played. So check time played. We're just running this every, I guess. Actually run it about, I think, every 60 seconds. Basically, it's a function that checks how long the user has been playing for, and then we send that how long the user's been playing for and their user ID to our Beamable microservice, which is running in the cloud. So this get total time played min. So this is another script here called playtime tracker. Let's open that script. And this is just some boilerplate code that basically is recording how long the app is open for. I did a little bit of kind of code here. So if the player hasn't touched the screen for more than 10 seconds, it'll stop counting the time. But if the player is touching the screen at least once every 10 seconds, it's going to be recording that, and it's just going to keep a track of how many minutes the user has been playing for. That's basically it. There's also another function to withdraw, which we basically just call our Beamable microservice to withdraw. So it's like the front end code is fairly simple. Let's head over to our Beamable microservice. So when we imported the ZBD template, it added our kind of backend microservice code here. And the main function here is game server. So we have a function here which gets the user ID and the total playtime in minutes from the client. There's kind of some stuff here. We're basically just doing some checks if the user is whitelisted, if they're blacklisted. I'll talk about that in a bit later. We're getting the current Bitcoin they have earned, and we're also getting the how much time they have been rewarded for in the past. So I think by default it's set to they get 10 sats every 5 minutes. So if I played for 10 minutes, then these sats should be 20 sats, and the current rewarded time should be 10 minutes. So these are kind of things we keep track to basically calculate how long they're playing for this time and how many more sats they will need to get. We just got some other things here. We're just checking to see if our Quago username, password, client ID, app token, ZBD API key. We're just making sure that they have all been set correctly. And these are something you set in the Beamable dashboard. Basically just a place to set config variables, API keys, passwords, things like that. If none of them are set correctly, we return an error, just reminding you to set them. Obviously, if you're not using Quago, you can remove this, but we are using Quago for this example. Next, we just basically want to get the Quago data by giving it the user ID, the username, password, client ID, app token, etc. And this returns a JSON object that we deserialize into this player info class that is a model here. You don't need to worry too much about it. It's just a clean way to deserialize the JSON. Yeah, so doing one thing here, we're just checking that we actually have some data from Quaggo. So when you actually first play, you might not get data from Quaggo for a while. I mean, it could take a minute or two. So we're just making sure it's set. And if it's set, then we want to check if the inauthentic playtime percentage or the emulated playtime percentage is greater than 0. So in my game, if it's inauthentic playtime percentage, that's basically a script or bot that's playing. So that's greater than 0. I just want to blacklist them. If they're playing on an emulator, I also don't want to allow that because it's just not good for ad revenue, etc. And also it's easier to cheat on the emulator. So yeah, if any of those are above 0 in my game, I'm just going to blacklist them, which on Beamable, I've added an inventory item called blacklist. So if the user has this blacklist item, they are blacklisted, and then I basically return an error, just kind of explaining why. I think how I handle this, I'll show in a bit how I handle this in the actual app is I just present an error to the user saying please contact support. I don't say you are blacklisted because sometimes that can make the user freak out. Maybe they didn't cheat, maybe it's like a bug in the code, false positive. So if you say blacklisted, they might freak out and give you 1 star on Play Store. But if you return please contact support, it's a bit softer, and you can unblacklist them if you believe they haven't been cheating. Anyway, once that's done, I'm basically getting the total playtime mins from the client. I'm subtracting the current rewarded time. So as I gave the example before, I've been playing for 10 minutes already. So I would have been rewarded twice because each reward time is 5 minutes for 10 sats. So say I've been playing an extra 5 minutes, the client is going to say I've been playing for 15 minutes. But because I've already rewarded 10 minutes of time, I do the 15 minutes, take away the 10 minutes, and I get 5 minutes, which means I can reward again. So then I would have been rewarded 3 times. The current rewarded time is saved as is saved at 15. Then when I play for 20 minutes or 5 minutes more, this will be 5 minutes again. So this code basically just makes sure it's looking at the 5-minute chunks. And how long the reward time is, it could be 5 minutes, it could be 10 minutes. This is all configurable in the Beamable backend, which I will show in the next video. I'm also doing some check here. You might want to remove this, you might want to keep it, but if there's a big... So Quaggo will tell me how long it thinks the user has played for. So I'm looking at this thing from Quaggo called total motion hours. So basically, Quaggo will tell you how long the user has been playing for, or how long the app has been open, and it's detected the app has been moving. So obviously, if a player is holding a phone, it's going to be moving because the player's hand is not, fixed, or they're going to be tapping the screen. So that kind of gives me a time frame there. The problem is it's not super great to do for rewarded time because, say the user plays for a minute, Quaggo might say they played for a minute. If they play for a minute extra, Quaggo might not say they played for 2 minutes, but give it another minute later, Quaggo will then kind of respond saying, oh, they play for 3 minutes now. So sometimes it doesn't update as quick as you would like it. And as you'll see in the UI UX, I want to kind of show every minute the user is playing, how close they are to that 5-minute goal, which is why I'm using the total playtime mins from the client, because I have control over that. It's real time, and I'm really just using Quaggo for kind of cheat detection. However, if there's a big discrepancy, like for example, my client is saying they've played for an hour, but Quaggo's only ever detected 5 minutes, and something is very strange here. They probably haven't been playing for an hour. So in my example, if the discrepancy is more than 20 minutes, I'm just not going to reward them any sats, because I think that doing something a bit suspicious, but you might want to change that. I mean, once you do this, I recommend testing this game out with some internal testers or in a beta, just to make sure for your particular game this anti-cheat code works for you. You might want to tweak it. It's probably not a good idea just to use this completely in your game, because you will get false positives, and all these things need to be tweaked specifically for your game. But as I mentioned before, this is a template just to get you started. Yeah, that's basically it. I just kind of return the current stats, so like how much Bitcoin they've got, how much time they need to play to get more Bitcoin, and this is all stuff that we'll show in the client, just to give a better UI UX experience. Lastly, we also got a function to withdraw Bitcoin, so we are storing the amount of Bitcoin the user has earned as another inventory item, and we just basically shoot this off to the ZBD API. We are using the send to email API. All this is in the ZBD API controller, doing basic REST requests. If you look at our documentation, it's all REST API, so just a basic kind of C# REST request. It's important to point out in Beamable, you can't use the Unity web request, because Beamable isn't running in the Unity engine, it's running in a C#.NET environment. So whilst you can write C#, if you haven't written pure C# before, you've only really written it for Unity, then you might be a bit confused. Why can't I use these Unity web requests, Unity random number? That's why. And of course, we're just basically passing the API key to it, which is safely stored in our Beamable config. So in the next video, I'm just going to go over and just have a look at some of the setup we have to do on Beamable. We have to just add some configs like our API key, our Quago credentials, and then I'm actually going to install on my phone and show the game playing, show how blacklisting works, show how whitelisting works, etc. So I'll see you in the next video. Thank you.